Yes, and dear students, and now we are going to start atomic structure and periodic table for quick revision of exam 2023. If we see the checklist, the first point in atomic structure is describe the structure of atom as a central nucleus containing neutron, proton, and surrounded by electron in shells. Sorry, before this, one thing we are missing, which is this one. This one is element, compound, and mixture. Describes the difference between element, molecule, compound, and mixture. Okay, a pure substance which has same type of atoms is element. For example, sodium, calcium, even hydrogen. Even though this is molecule, but this is the molecule of an element. And same way, O2 is the molecule element, but the also molecule. So we can say this is the molecule of an element. Okay, so if you see molecule, what is then molecule? Combination of two or more atoms. When two or more atoms combine, it is called molecules. Means to a single atom, just for noble gases which are monatomic molecule, you can say monatomic molecule. Otherwise, all those species which have two or more atoms combine chemically with each other, combine by forming a covalent bond, are called molecules. Here I have given two examples of molecule, H2, O2, same way H2O, this is the molecule of compound because it contains two different elements. Okay, SO2, sulfur dioxide, this is the molecule of compound again. H2SO4, this is the molecule of compound as well. It contains hydrogen, sulfur, and oxygen. Okay, so if we see the example of compound, again, we discussed when two or more different elements chemically combine, instead of elements, you can also say atoms. That is, when two or more different atoms chemically combine to form a compound, to form a molecule, to form a formula unit. Here I have used a word formula unit. Basically, formula unit is used to explain, used to give the name to ionic compound. For ionic compound, we cannot use the word molecule. This is better. You have to use formula unit. Okay. And lastly, in this topic, we will see mixture. When two or more things physically combined, not chemically, without any fixed ratio, such type of species, such type of substances are called mixture. We can see the example of this topic from the exam paper. If you see this exam specimen paper, in this specimen paper, you can see that in this balloon, he is asking which diagram shows the arrangement of the particles inside a balloon containing a mixture of the gases, nitrogen and oxygen. Means nitrogen, for nitrogen, we have to write N2. For oxygen, we have to write O2, or we can represent it like this way and this way. These two dots are indicating two atoms of each molecule, two atoms in each molecule. So this can be N2, 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 this can be O2. Okay. This is also representing N2, O2. So this is not N2 and O2. Why N2, O2? Because these are two different atoms. This is nitrogen, this is oxygen. So this can be a molecule of compound, but not the molecule of nitrogen and oxygen, which are element. Okay, now among B and C, which one is the best possible option? It is C, because these are randomly arranged, not in a regular pattern. So it is clear from this example as well. And we have seen it in the quick revision or checklist that he is asking about element, mixture, molecule. Hope you are clear with it. So now we will move toward atomic structure. Okay, if we see in atomic structure, the first check list is showing that students should know, describe the structure of the atom as a central nucleus containing neutron and proton surrounded by electron in a shell. Okay, this actually atom is just a nucleus. Shells are imaginary path in which there are electrons. Remember, if an atom contain 8 proton, this atom also contain 8 electron. That is, in an atom, number of proton and electron are same. That's why an atom is electrically neutral. For example, if we take the example of oxygen, it has 8 proton and 8 electron. That's why atom is electrically neutral. Then why it get negative or positive? Any atom get positive or negative charge. It get positive or negative charge when it gain or lose electron. We will discuss it, which is called ion. We will see in the topic of ion what is an ion. If we see this checklist again, describe the structure of the atom as central nucleus, that is, nucleus is in the center containing neutron and proton. Okay, what is in the nucleus? Neutron and proton. Neutron number may be differ from proton or may be equal to proton number. Okay, for example, in case of oxygen, there are 8 proton as well as 8 neutron. The sum of proton and neutron in the nucleus is called nucleon number, which is represented with A. Proton plus neutron. Here I have shown it roughly, but you can understand. This is showing mass number or nucleon number. Why this is called nucleon number? If you see or observe the name, this name is indicating that the number inside the nucleus. What number? Number of proton and neutron. Total sum of proton and neutron. We can make the equation for nucleon number. A is equal to proton in the nucleus plus neutron in the nucleus. Hope you are clear with this. This also indicating proton number and nucleon number. Okay, proton surrounded by electron in a shell. Okay, it already clear that there are same number of electron and these electron exist in imaginary paths which are called shell. For example, in first shell, there are always 2 electron, maximum 2 electron. It can be 1 in case of hydrogen. Then in second shell, you can place 8 electron, but these can be less than 8, 2, 3, 4, 5, even 1. We will discuss this in a periodic table portion, which is coming in this chapter as well. Okay, so this is clear, hope so. Now, we will see define proton number, atomic number as the number of protons in the nucleus of an atom. Yes, in a symbol, for example, this is the symbol of sodium atom. In this you can see 11 proton and 23 is its nucleon number. This means it contains 11 proton. And what is the difference of 23 minus 11? This is equal to 12. Means it contains 12 neutron. Means it contains 12 neutron. Okay, so you are clear with proton number. This is also called atomic number. Number of proton in an atom, in the nucleus of an atom, is called proton number. Okay, next is define mass number, nucleon number as the total number of protons and neutrons in the nucleus of an atom. I have explained this with the help of this revision checklist. So hope so you are clear with nucleon number, proton number and mass number. Again, sum of proton and neutron in the nucleus of an atom is called nucleon number. Okay, we can see the example of this from the examination paper. If we see this specimen paper, in this specimen paper, if you see, he is asking atoms and ion contain proton, neutron and electron. Okay, proton What is the charge on proton? It is +1. Remember it. Relative mass, it is 1. Neutron charge is 0, or you can say neutral, but specifically the charge is 0. Electron charge is -1. When we say about the mass of electron, it is negligible. We will consider it as a negligible, R1 by 84,000, or you can say it is negligible. You have seen the question. It is of 3 marks. Very easy question. If you are familiar with the structure, basic structure of atom, you can give the answer of this one. Okay. Show some information about 6 particles. Yes, this will come next. In next topic, we will see it. What checklist is saying and what checklist is asking about this question. We will see it. Wait. Okay. Now, if we see this 5th checklist, determine the electronic configuration of an element with proton number 1 to 20. Okay, for this, I would like to open whiteboard. On whiteboard, we will see what is this. If you give me a 1 minute, I would like to show you on this whiteboard. Okay. Yes, electronic configuration of elements. This electronic configuration help us in many ways. How this help us, I will explain this. I would like to use eraser here. Okay. Okay, Ji. Yes. Now I share this with you. Okay. If we see calcium, what is the proton number of calcium? It is 20. It indicates that it has 2 electron in its first shell. We can place maximum 2 electron in first shell, and 8 electron in second shell. We can place 8 electron in second shell. Okay, 2, 8. Remember, for O-level students, you have to just place 8 electron after first shell, and not more than 8. It can be less than 8, but not more than 8. Okay, 2, 8 out of 20, we have placed 20 electron here. Now again in third shell, 8 electron, it becomes 18, and lastly it is 2. This is showing how many shells are there. 1, 2, 3, 4. This shows that it is in third period. From this, you can learn that shell number indicate period number in periodic table, and number of valence electron indicate group number. That is, it is in second group and fourth period. If you see periodic table, in periodic table, it is in fourth period and second group. Again, I would like to move toward checklist. If we see in checklist, determine the electronic configuration of element with proton number 1 to 20, for example, 283. Okay, if we see this 283, this 3 indicating it is in third group, 283, third shell, 3 shells indicating that it is in third shell, and how many total number of electron? 8 to 10 and 3, 13. It is probably obviously it is aluminum, which is in third group with proton number 13. State that 7 8 noble gases have a full outer shell. Okay, group 7 noble gases have full outer shell. What do you mean by outer shell, full outer shell? Only helium has, in case of helium, there are two electrons, which is first shell as well as last shell. So it has two electron. There was a question in this question is asking, every noble gas has 8 electron in its outer shell. No, this is not the answer. Every noble gas has complete outermost shell. If it is helium, this is 2, that is duplet. Other than helium, all noble gases have 8 electron in their last shell. For example, here I would like to show you electronic configuration of argon 2. This is showing electronic configuration as well as number of electron in last shell. 2, 8, 8 to 10. So remainings are 8. These are in last shell. 2, 8, 8. This is in third period, as there are 3 shells, 1, 2, 3 shells, and it is showing it is in 8th group or 0 group or noble gases group, which it has written here. So again, noble gases has complete outermost shell. It is not necessarily 8 electron in outer shell. It can be 2, for example, in case of helium. Okay, the number of occupied electron shell is equal to the period number. Yes, we are clear with this one. So you are clear. And the number of in last shell indicate this is in case of atom, if the electronic configuration of atom. Okay. Now we will move toward next topic, which are isotopes. Very important topic. Isotopes. Iso means basically same. Atoms of same element. Again, atoms of same elements which have same proton number. Again, same proton number. This is indicating that proton number is the unique property of an element. Proton number is the unique property of an element. That is, every hydrogen atom must have proton number 1. Hydrogen 1. Hydrogen 1. Hydrogen 1. If it is hydrogen, it has proton number 1. If it is carbon, it has proton number 12. Carbon 12. Again, a very small hint for you. The smaller number in the symbol of an element is proton number. Larger number is indicating nucleon number. Sorry, for carbon, I have written here 12. It is not 12. It is 6. It is 6 again. 6, 6, 6. Okay, it can has isotope 12 and 13. So what do you meant by isotopes? So from this we can conclude isotopes are the atoms of an element which have same proton number but different nucleon number or mass number. Nucleon number can be same as of proton number. This means there is no neutron. If proton number and nucleon number is same, this means there is no neutron. Okay, in the case of 1H2, 2 mean nucleon number. Here is 1 proton and 1 neutron. And in case of 1H3, there is the possibility of 2 neutron and 1 proton. Okay, again, isotopes are chemically same. They have same chemical properties. They form same type of compound. For example, if water is forming with the isotope 1 and with the isotope 2, 1H2, the H2O, it will form H2O, but it may have masses. For example, both hydrogen, these 2 hydrogen, both are this one, then 2, the mass number is 1. The total mass of hydrogen in the water become 2, 2 plus 16, it become 18. Okay, if 1 hydrogen is of 1 and 1 hydrogen is of 2, then it become, it is a H2O again, but its mass is 19 because 1 hydrogen is of 20. There is another possibility of water mass, that is H2O, that both hydrogen, although this has very less probability, very less chances of this, but it can be. So the mass of this water, which contain both hydrogen of 2, the mass become 20. So from this, we can conclude that isotopes have same chemical properties, but different physical properties. This question was in the exam. In this question, specific question, he asked, if a water molecule is formed with the help of these isotopes, what are the possibilities of the masses of water? So there are 3 possibilities, 18, 19, and 20. Again, I would like to go to checklist. Define isotopes as different atoms of the same element that have same proton number or same number of protons but different numbers of neutron. Due to different number of neutron, their mass number changes. So in the definition, you can say atoms with same proton number but different neutron number, are atoms with same proton number but different nucleon number, because nucleon number is the contribution of proton as well as neutron, is the sum of proton as well as neutron. Okay, next, state that the isotopes of the same element have same chemical properties because they have same number of electrons. Okay, from this we learned that the chemical properties are totally related to the electronic configuration, totally related to the number of electron, totally related to the number of electron in valence shell. That's why again, listen this point, atoms in a same group almost have same chemical properties. For example, atoms in first group always have same chemical properties. Atoms in second group have same chemical properties. Atoms in seventh group have same chemical properties. Clear? For example, sodium when react with oxygen form ionic compound. Sodium when react with, again, potassium when react with oxygen. Here oxygen is constant, form ionic compound. So same chemical properties. Interrupt and use symbol for atom. For example, carbon 12, this indicating 6. Okay, chlorine 17, again the smaller number indicating proton number and larger number indicating nucleon number. What is the difference between this chlorine and this chlorine is 35 and 17? What is the difference between this chlorine and this chloride? This one is chloride because it has negative charge. Chloride, bromide, iodide, we have to use word for ion. When it gain one electron, it become negatively charged. But with the gaining of electron, proton number will not change. It is 17. Electron number is changed. So just the number of electron in this chlorine, one electron is gained, so it become 18. 18 electron in the chlorine atom. Hope so you are clear with this. Calculate the relative atomic mass of an element from the relative masses and the abundance of its isotopes. Okay, for this, I would like to go to whiteboard here. Yes, here. Chlorine. If we see chlorine has 2 isotopes. In this checklist, he's asking students should know what is, how to calculate relative atomic mass. For example, chlorine has 2 isotopes, 17, 35, and chlorine 37. This means it has 35 minus 17. How many neutrons it have? 35 minus 17. It is 18 neutron. In case of 37, it has 20 neutrons. So from this, we can conclude these are isotopes because they have different neutron number or different nucleon number. Okay, their percentages will be given in O level. 35 exists as 75% in nature and chlorine exists as 25% in nature. Obviously, if it is 75, then remaining is 25. So when you have given isotopic mass, relative atomic mass of chlorine is 35.5. What is the difference between relative atomic mass and isotopic mass, or simply atomic mass? Atomic mass is a whole number. It is just of one atom. Relative atomic mass is the mass of its all isotopes, average mass of its all isotopes. How to calculate it? I'm going to give the example. In case of this one, 35 is the isotopic mass. Multiply this isotopic mass with its percentage abundance, 75% plus 37 multiplied 25 divided by 100, that is 25%. When you calculate, you will get the answer 35.5. This is the way and how you can calculate relative atomic mass of an element. Again, to calculate relative atomic mass of an element, you will be given isotopic mass of each isotope. If it has two isotopes, isotopic mass of both isotopes, and percentage abundance of each isotope. Okay, when you have given isotopic mass, multiply this isotopic mass with its percentage. Again, second isotopic mass with its percentage. After calculation, add the answer, you will get 35.5. This is called AR, relative atomic mass of an element. Relative atomic mass is always of an element, and atomic mass is always of an atom. Here you can see, calculate the relative atomic mass of an element from the relative masses and abundance of its isotopes. Hope you are clear with this. Okay, next checklist is showing that students should know what are ions and ionic bonding. We will see this in bonding chapter. Here, hope so you are clear with the atomic structure. I would like to show you some question related to atomic structure again. Here you can see table shows some information about 6 particles. For the revision of 2023 exam, I tried to choose the questions from specimen paper, so it become more relevant with your current exam. Okay, table 2.2 shows some information about 6 particles. Deduce the nucleon number for particle A. Okay, it become easier now. Number of protons 37, number of neutron 48, number of electrons 37. Again, if proton and electron are same, this means it is atom, it is not ion. Deduce the nucleon number for particle A. So what you will do? You will add the proton number and neutron number, 37 plus 48, and check the answer. It become 5 and 85. So hope it is clear. In this way, you will calculate the nucleon number. After calculating nucleon number, we will see next question. What is next question is saying? Explain why particle B is a negative ion. Okay, very good. Very relevant to our topic. B, what are the proton number in this? 53. Okay, and electron are 54. One more electron, as it gain one electron. What is the answer? Explain why particle B is a negative ion. It gain one electron. Its proton number is 53. It gain one electron. It is just of 1 mark. So the only answer is, as this particle gain one electron, one more electron. It has one more electron. Whatever you would like to say. Identify 2 atoms that are isotopes of the same element. Okay, isotopes have same proton number. This one, this one, this one, same proton number. Okay, and what about their neutron number? 146 and 143, means C, D are isotopes. D specifically because it is no, isotopes, 143 atoms atom. Why atoms? At same number of proton and electron. Okay, so here you will write C and D, more specifically C and E, sorry, C and E. C and E are isotopes of each other. So hope you are clear with the relevant example. Explain your answer. Here is asking what is the explanation of your answer. So what will be the explanation? I'm giving pause here. Revise explanation in your mind. So explanation is that they have same proton number, but different neutron number. They have same proton number, but different neutron number. I would also like to show you some questions from MCQ paper. In MCQ paper, if you see the symbol for two ions are shown, F minus, Na positive. Okay, atoms form ions. We will discuss this in a bonding chapter. Interestingly, if you see, after gaining one electron, it has gained one electron. How would we know that it gained one electron? It has negative charge. It has lost one electron. How would we know that it has lost one electron? It has positive charge. Positive one mean it has lost one electron. So 10 electron, it also has 10 electron. Proton number remains same, but electron number changes in ion. Which statement is correct? The fluoride ion contain more electron than the sodium ion? No. The sodium ion contain more neutron than the fluoride ion. Okay, in fluoride ion and 10 and 10, both have same. The two ions contain the same number of electrons as each other. So this is the best option. Okay. Here I am seeing another example related to isotopes. Very relevant example to our syllabus, our checklist. Two isotopes of chlorine are chlorine 35, chlorine 37. Using these isotopes, how many different relative molecular masses are possible for the compound with the molecular formula C2H3Cl3? Okay, very interesting question. Here, the only changes are because of chlorine. One possibility is that all chlorine are of 35, 35 plus 35. This is the one option, one. And second option is two chlorines are of 35, 35, and one chlorine is are of 37. Okay, this is the second option. Okay, and the third option is one is of 35 and two are of 37 plus 37. So the last example is all are of 37, 37 and 37. So three chlorine, three possibilities, arrangements, possibilities of atoms. So combination will be 4. The answer is 4. From this, what we have concluded, these all 4 have different molecular mass. We conclude that they have same chemical properties. The chemical formula remains same, but physical properties will be changed. That's end with atomic structure. Hope you are clear with this topic. Next will be ionic bonding and covalent bonding and metallic bonding. Means next chapter will be bonding. I will try to upload this video as soon as possible. Thank you.